Hey, welcome back to Native JS again. So today we are back with again Python related projects which we create on Native JS series, right? So we are back. So what my aim is on this Native JS is we'll be creating GIS videos, Geo AI related videos, what are going on in the industries. So we'll be coming off with new ideas, but for now, this Python related and for GeoAI related projects. So what we'll be doing is I'll be doing some of the videos live and I'll be recording some of the videos. Like for now, this video has been recorded and I'll be publishing the whole raw video of how I am doing the project, how it is being done, and that live coding and everything I'll be doing, how we are solving it. That thing will be doing in this particular video, but I'll also add a summarized part of this video. Let's say it can be 10 minute to 12 minute or maybe 15 minutes depend upon the video content, and we'll be adding that in the GitHub, and I'll add that GitHub link in the summarized video when I'll be publishing that. And after that you can check it out, you can also do those projects at your end, and you can also learn like okay how these things has been done. Okay, so mainly our goal will be let's learn together and let's find it out like how it is being done. So basically welcome to Native JS again, guys. So you know how we are doing, we are continuously producing videos. I require your help, and if you can help me, so please subscribe to the channel and like my videos. That will be one only one help which I require. And please, if you provide some good comments on our videos, that will also be a great thing. Let's go and start this uh, project work. Okay, so now the project which we are going to do is on population density mapping graded. So mainly you can say that this is a full project or an enhanced version of, there are a lot of population density mapping which are being done from, you can get from the YouTube as well. But okay, let's try it out from our end how we'll be doing it. If you are fine okay with this project, then you can check for the further thing and you can see like how it is being going and you can find it out. Okay, so for now let's say uh, what we'll be doing is we'll the task which we will be doing on this is create a fishnet grid, overlay population raster, and then summarize the population per grid cell. Okay, so this will be the our task on this particular project which we will be doing. So data will be, let's say we can take the world population data, or we can take some other data as well, whatever you want. Skills will be zonal statistics, grid creation. These are the skills which will be we require on this thing. Tools will be raster stats, geopandas, rasterio, matplotlib, and folium. Okay, so what I'm thinking is let's say we can start with the project understanding and how we are framing it. We can understand that. Okay, so what we are doing, we take a population raster. Each pixel is equal to the number, some number of peoples. We create a grid, let's say fishnet, and calculate how many people fall in each grade cell. This gives us a specially uniform population density map. Now, this is what we will be doing in this particular project. Okay, so why this matter? Okay, population density grids helps with let's say various things. One will be urban planning, let's say schools, hospitals, roads, disaster risk planning, let's say evacuation zones. So you can say that I'm from India and I'm from Odisha as well, and I know that in Odisha a lot of cyclones are being there. Means they hit in each, I say two cyclones hit per year. So there should be data which we should know, like how much population needs evacuation zones, or what evacuation zones need to be created. So all those things need to be there. Another thing will be, let's say, market analysis, like the store locations. uh, there are other characteristics, let's say, or other, or what I can say, significance of this thing will be on the telecom industries, on utilities industries, tower placement, so they can see all this population density grids, and they can build out their projects. Okay, now the GIS concepts which are involved is, one will be, here we will be discussing about raster metadata, the resolution, CRS, extent, all those things. Fishnet grid extension or fishnet grid creation, raster vector interaction, zonal statistics, and chloropath mapping. Okay, so I actually, why I am why what I was doing is, I have note down some of points on my list, and some of them are I am remembering as well. Okay, so that's why I might fumble a bit, but yeah, this is my first creational video like this, so please support me. Okay, so now the thing will be, what the final output will be like. Let's say will be the final output which will be achieving, that might be a grid layer with population per cell, chlorophyll maps, static plus interactive, summary stats will be there, like 10 high density cells, where the population is more, where the population density is more, so that will be there. Okay, so now let's say, uh, as I am also thinking about, let's create, or let's assume like we are a project manager, right? All those project managers who are seeing this video might get a chance, or they can think like, okay, what we are doing. So that's why I also created this project in a bit of project structure or architecture, what all things. So we'll discuss them as well, so that it could help others to get to know like how the project management is going, how the project structure is created, what is the architecture is being created. If you want to work on a small projects, so we can discuss them as well. Okay, so the project structure and the architecture will be like, let's say, first we'll be developing this on Google Colab notebook. Okay, so I have a pro version of Google, which I have taken on a particular Gmail account. On there I get some space, and as well as some, let's say, you will get a good quality of running space where you can run the code on the Google Colab notebook. There are free versions as well. I have not tried it, but you can try it at your end, and you can tell me in this video, or in the summarized video when I'll be publishing that what are the challenges you are facing when you run this code on the Google Colab free version. Okay, so try it out, and let's see, like, let's learn together. And yeah, now getting back into the Google Colab notebook structure, first will be the project title, overview, introduction, and our problem statement, which we have already discussed. What are the data sources, install and import of the libraries, what are the libraries that will be importing or installing in this. Then load the population raster. Sixth will be load and create AOI, area of interest. Reproject the area of interest into for a grid creation. Okay, then create fishnet grid. Reproject grid back to raster CRS. Then run zonal statistics. then compute area and density. Then after that, visualize population grid map. Interactive map will be the optional one. Then the summary and insights, limitations, and the next steps. Okay, so these are, let's say I have divided this whole thing into 15 points. So if you want, I'll recollect them once again. So the Google Colab notebook structure are: first will be project title and overview. Second will be introduction and problem statement. Third will be data sources. Fourth will be install and import libraries. Fifth will be load population raster. Sixth will be load the area of interest, or we will be creating our area of interest. Then we'll be reprojecting that area of interest as per grid creation. Then we'll create a fishnet grid. Then we'll be reproject grid back to the raster CRS. That's the ninth one. Then the 10th one will be run zonal statistics. 11th one will be compute area and density. Then 12th one will be visualize population grid map. 13th will be interactive map. We can create an interactive map. That will be optional thing, but we can create it. 14th will be summary and insights. 15th will be limitation and next step. So this is a project structure which we can create for this project. Okay. Now what I'll be doing is, when we will complete this project, I'll populate this particular code, or let's say what we have developed. I'll add it into the GitHub repository, and I'll share that link as well, where you can go and you can check the structure as well. You can see why we are doing it, what is the significance of what we are doing. So all these things of this particular project will be available in the GitHub, so that it will also be created as a portfolio for me, and as well as you can download it and you can create for your area of interest. You can create or any other things, the next steps or the next steps which can be done on this particular project. Let's say you will be analyzing a market analysis, and you can see that where the store locations will be there. You can use this project. Or let's say whatever particular which we have discussed, like what are the significance of this project, where it will be used, like urban planning, disaster risk, market analysis, telecoms and utilities. So on those next steps you can utilize this after learning this. Okay, so now let's start with the project, and let's see why we are doing it, what is the significance of it, and let's build it. Okay, so guys, now what we'll be doing is, we'll be uploading the raster file which we have downloaded to our Colab environment, and then after that we'll be installing the libraries, then the set of directories, then load the raster into that, and then after that we'll be doing it. Okay, so before any special analysis, we need the raster files, so geotiff available in which we need to be get it available in the Colab environment, since the Colab resets the environment each time. Uploading the file manually will ensure that it will be available for reading and processing it. Okay, so basically how what from where we will get this uh, thing is, so let's say we can do one thing will be like, we can go to world population data, and from there we can get the things. And another one will be, let's say, we can get it from the gridded population of world. From there as well we can get it. So let's say I'll just show you like how we'll be getting it. So this will be world population data catalog, and then inside that there is a data thing is there. So inside data, you will be clicking it. There will be this population count. So click on population count. Go to individual countries, and in individual countries, write as I will be doing for India. So in India, from 2015 is there. So you can go and download the. You will click on it, and it will get downloaded. Okay. So I have already done it. So I'll be not doing. And it would might be taking you, let's say, some 30 minutes of time, because the speed depends, and I have a good speed, but still it took around what I'll say, uh, it took around 30 minutes, I guess. So yeah, so what we can do is we can work after that. Okay, so now let's uh, add that. So here the resolution will be mainly 100-meter or 1 kilometer. The CRS projection system is basically EPSG 4326. Okay, so what we'll be doing is we'll be uploading the raster to the Colab. Okay, so let's write it like upload the raster to Colab environment. Okay, so let's import OS. Then from Google Chrome import files, import raster view, and then the step one will be create a folder that will be content slash data. Okay, and so already I have created the steps, so I am not writing again. Where we need to be writing, we'll be writing it. Okay, so then we got this Indirapuram population per 500-meter grid. So according to this map, what is our analysis? I have written it down. So let's see. So we have dark red areas, which is 606 per 500-meter grid, means that particular grid value. So it is population is like analysis of the above map. So map shows the total number of people living in each cell grid. Population is equal to the absolute population, absolute people count. So let me add it into another. So is equal to absolute. Then the analysis of the map is population per 500 meter grid is equal to absolute population. So what this map shows is, like, if you'll see, so the total number of people living inside each grid cell regardless the area. Color meaning the dark red is 6,000 to 8,700. You can see. Uh, then the medium red, then the orange, and the yellow and cream. So the key observations is like the central and northwestern Indirapuram have the highest populations. These areas hold 7,000 to 8,700 people per 500-meter block, showing high occupancy per building, dense apartment clusters, popular residential pockets. Okay, so this is how you can analyze the population density, and then put high analysis. You can do advanced analysis on these things. So then some grid cells with medium population still shows high density. This happens when a shell of has few buildings, but each is very crowded. Lots of mid-size apartments packed into small areas. Then the sparse population will be parks, playground, empty lots, commercial complex, and the main roads. Okay. Then this is the grid which we have put. Okay. So basically this is the Indirapuram area, if you'll see. Okay. So if you'll see here, the density and the calculation of population has been there. So let's say we have so where I was before leaving was the Nitikhand part. So here, so you can see, right, the population density which we are grabbing on this particular cell is 6644. Okay, so the density is also high, so we'll also check the density. So sorry guys. So this map will be highlight the areas that are crowded, not just the high population. Okay, so we get this map through this particular code. So if you see Indirapuram population density hotspots, people per kilometer. Okay, so the analysis that done on this particular map, it shows that density is equal to pressure uh, on a area, that is basically the crowding. Okay, so what this map shows the highlight tight people are packed into each particular cell. Then if you'll see that the dark teal, that is around 2000 to 38,000 per square kilometer. Okay, this dark teal areas, these are the areas, right? And these are the areas which I was also showing in the above. If you'll see that, okay, uh, this one, it's 23,000, right? So it has the higher value on this thing, uh, on this particular part as well. So these are the color combinations and the density that has been added over here. And the key observations will be northern Indirapuram is the densest area zone, and very little open space, many multi-storied apartments. So this is the analysis that I have done based on the density key factors. So high occupancy residential, as it is Indirapuram is a town, so it is basically a urban thing. So how I got to know that it is a multi-storied or everything, I also know that, means I do also know Indirapuram area, so that's why I can make the ground truthing same. So which is also you can say that actual data which this particular analysis has been provided. So Cyprus City is a society over there which has the dense pockets, Gankhand parts, Nitikhand. Also, these are the high occupants. These are small packets where many people is living. So similarly, some central pockets are surprising sparse, white and light patches in the middle indicates like parks, open ground, commercial building, road intersections, under construction and institutional areas. Density drops towards southern is from south to southeast zones. It is like more open plots, wider roads, low rise housing or something like that. And the summary table that we got, that if you'll see the mean is 4075, like at least the counts cells are like around 195 cells which we have, or the grid that we have taken, and in that mean is 4075. Standard median is I think 216, mean is 11, 25% is 23, 50% is 4270, 75% maximum is 8711 in a particular grid. Okay, so the most top populated cells is 6063. This is the grid number, and then the population sum and the density. Okay, that you can save it in. And the analysis which we done on this particular data. Okay, so that also I have added it. So let's begin with our analysis. So the study area, that is Indirapuram, Ghaziabad, was divided into 195 grid cells, each measuring 500 meter by 500 meter, the cell area which we have taken. So this is the cell area, you can see. Let me just zoom out a bit. So this is the scale area. So it is a bit covering the Khaga area, sector 62, 63. But yeah, we can clip the Indirapuram area, and this is basically the grid which I look into. uh, and yes. So the key statistics, what they tell us is count is 195, number of grid cells in Indirapuram is covered by, not Indirapuram, I'll say Indirapuram plus the nearby areas like 500 meter by 500 grid. Let's say that comes with the sector 62, 63, all those things. Mean people, the average population per grid is coming around 4075. Then the standard is variation in population, high density variation. Some cells are far more populated, that is 2166. Minimum is 11 people. Least 25% is 2340. Low density quartile, like you can say that 2000 people are living in 25% of those grids. 50%, that is the median, you can say 4240. 75% is 5634. Then the max number, as I say, 8711. So that is the count which you will get over here. So that is what I have interpreted out. So what this means in simple words, most of the Indirapuram is moderately highly populated with 4000 to 5500 people per 500-meter block. So this is a strong density contrast. Some cells have few dozens of people like parks and roads, while dense apartment clusters around 7,000 to 8,700 peoples. So this confirms Indrapuram is a high density residential node for or node of NCR. Okay, so that's why there are a lot of things we can calculate from it. Means let's say um, the areas where we can put the store locations. Let's say the area where we can build what we can build the stores, we can build malls, we can build shops, and we can build hospital, we can build ATMs, all those things which needed for population. Okay, those we can build on those things. So 10 most populated cells like 60, 63, 59, you can identify those areas. After identifying those areas, so what I got to know, like these cells represent the densest part in the Indirapuram high-rise apartment clusters, compact multi-storied housing areas with minimum open space. Classic, it's a classic case of high NCR, high density urban morphology. Okay, so some examples will be Mumbai suburbs and South Delhi colonies, Gurgaon apartment belts, all those things. Urban planning meaning over here will be infrastructure demand zones. Okay. High service pressure shells like water, electricity, waste. So when you build a particular township area, or you can say a particular town, all these factors needed, man. Means, and after in going into the future, you also need like what things needed on this particular area, so that we can avail those services to the public and they can use that. So that you can say that if a particular area has a demand, if we in a nearby area where the demand is less, if we build something good over there, a township over there, then some people might transfer to there, so that the uh, area will not be much congested after on that particular you can say specific area, right? So this is what potential congestion hotspots are there, areas suitable for target mobility planning, zones where social amenities may need reinforcement. Okay, so now combining both maps, what analysis I got will be like high population plus high density, severe pressure zone. Okay, high population plus moderate density, it is balanced apartment zones. Low population, high density, few buildings, but extremely crowded. Low population plus low density, open areas, park and commercial roads. So this is the basic analysis what we can get from the two maps. So analysis about Indrapuram's urban structure. So this is the basic analysis which can provide. So what this means about Indrapuram urban structure is a classic high density township most population clusters is around 4,000 to 6,000 per 500-meter cell. Residential blocks are extremely compact, high population and high density multiple cells, very little open space in some mid-northern parts. Urban planning pressure is high in hotspot cells. Water supply demand, waste generations, mobility congestion, public safety loads, green space deficits. Some southern and central pockets shows opportunity zones for cloud support, new infrastructure, more open space, lower population footprints. And the final summary what we can provide to you guys, and this is how you can build your summaries as well. In Indirapuram, population per 500 meter grid ranges from as low as 11 people to high as 8,700 people per cell. When we convert this to density, the hotspot region crosses 30,000 to 38,000 per square mil people per square kilometer, indicating extremely compact urban settlements. The densest region appear in the northwest and central sectors, areas dominated by multi-storied apartments. Meanwhile, the lighter zone levels reveal parks, commercial pockets, and open spaces. Together, these maps help planners to identify which areas where the services and infrastructure need to be strengthened, where population pressure is highest, and which area can be used as a support for future growth. So this is what we have developed from this project, guys. So it's a now 2 hour plus video, but yeah, I think it is fruitful that we have come to a conclusion of a area like how we can be creating a project on this population density mapping. So I think this is a very good case. If you will go through whole project, you will be getting the whole analysis. So what I believe, I'll be putting this into the GitHub and all the analysis and all those things what we have done. And you can also do it for your areas, for whole India, I guess, if you have the good system and everything. But what I'll guess is, please do one support to me, like you subscribe to this video and like this video as well as the summarized video which I'll be publishing, where the GitHub link and everything will be there, where you can check it and you can also create a portfolio from it. But I need support from you guys, so please like, share, subscribe to Native GIS. And yeah, let's build more and more projects. Okay, that's all. Bye bye, take care. Workflows. Thanks for watching. If you found this video helpful, give it a thumbs up, subscribe to the channel, and hit the bell icon to stay updated on the latest in AI and GIS. See you in the next video.